Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for continuous random variable. Given the question, the following is the probability density function of a continuous random variable x, and here we have the piecewise function. My suggestion is to represent the situation in a number line. So here we have 0 until 2 with the function x over 3. Next, from 2 to 3, where we have the function 2 multiplied with 3 minus x over 3. Otherwise, we have the function 0. By referring to the question, sketch the graph and show that x is a continuous random variable. So my first task is to show that it is a continuous random variable. So integrate, start from 0 to 2, where we have the function x over 3 respect to x, plus where we have 2 over 3, factor out the 2 over 3, integrate where we have 3 minus x respect to x for the limit 2 until 3. So kindly integrate the situation where we have x squared over 6 with the limit 2 and 0, plus where we have 2 over 3 bracket 3 minus x to the power of 2 over 2 multiply with the negative 1 because we differentiate the internal function with the limit 3 and 2. Next, substitute the value where we have 4 over 6 minus 0 minus 1 over 3 where we have bracket. Kindly substitute the 3 and we will obtain 0 minus, if we substitute 2 and we will have 1. Simplify the situation where we have 2 over 3 plus with 1 over 3. So as a conclusion, integrate from the negative infinity until infinity for the function fx with respect to x is equals to 1. So show that it is a continuous random variable. Next, what we have to do is to sketch the graph. So kindly have an xy axis. So kindly substitute the situation. If we substitute 0, and we will obtain 0. If we substitute 2, then we will have 2 over 3. So let's say here we have 1 over 3, 2 over 3. 1 and 2. So by referring to the situation where we have x over 3, which is a straight line equation. Next, kindly focus on 2 to 3, where we have 2, this one is 2 over 3, this one is 1 over 3. So where we have 3, if we substitute 2, again, we will have 2 over 3. If we substitute 3, then we will obtain 0. So again, refers to the situation where we have a straight line equation as well. So do remember to name the situation where we have in here fx is equals to 2 multiplied with 3 minus x over 3. Whereas for this part, where we have fx is equals to x over 3. So here will be the graph for the probability density function. Next, find A, where we have the probabilities that x less than equals to 1. By referring to the number line, where we have integrate 0 until 1 for the function x over 3 respect to x. Kindly integrate the situation x squared over 6 with the limit 1, 0. So the probabilities that x less than equals to 1 will be equals to 1 over 6 minus 0. So the probabilities of x less than equals to 1 will be equals to 1 over 6. B. Find the probabilities that x is greater than equals to 0.5. So here we have the probabilities that x greater equals to 0.5. So my suggestion is to modify the situation where we have 1 minus the probabilities that x less than equals to 0.5. So where we have 1 minus integrate start from 0 until 0.5 for the function x over 3 respect to x. Kindly integrate the situation where we have x squared over 6 for the limit 1 over 2 and 0. 1 minus bracket. If we substitute 1 over 2, and we will have 1 over 4 over with 6 minus the 0. 1 minus, where we will have 1 over 24. So finally, the probability is that x greater equals to 0.5 will be equals to 23 over 24. Kindly refers to C. Find the probability that with the modulus x minus 2 less than equals to 0.5. So what we have to do is to define the situation modulus of x minus 2 less than equals to 0.5. So the situation is an AND situation. Probability stat bracket where we have x minus 2 is greater than equals to negative 0.5 less than equals to 0.5. So this is what we call based on the definition of an absolute value. Simplify the situation. Probability that x is greater than equals to, where we have 2 minus 0.5, we will have 1.5. Less than equals to 2 plus with the 0.5, where we will have 2.5. That will be the situation after we define the modulus of x minus 2 less than equals to 0.5. Next, by referring to the situation where we have two sections, integrate start from 1.5 until 2, where we have the function x over 3 respect to x, plus integrate start from 2 until 2.5 for the function 2 over 3 multiply with 3 minus x respect to x. Kindly integrate the situation where we have x squared over 6. So my suggestion is to factor out the 1 over 6, and we have the value 2, and then 1.5 is equals to 3 over 2. Plus, where we have 3 minus x, if we integrate the situation, and we will have 3 minus x to the power of 2 over 2. Do remember to differentiate the internal function, where we have negative 1. So 2.5 will be equals to 5 over 2, then 2. Before we further our discussion, kindly simplify the situation. The value. So here we will have 1 over 6 bracket. Substitute the 2, so we will have 4 minus, if 3 over 2 will become 9 over 4. Simplify the situation. So 1 over 6 multiply with 7 over 4. Next, focus on the next part. Before we substitute the value, kindly simplify the situation where we will have negative 1 over 3 bracket 3 minus x to the power of 2 with the value 5 over 2 and 2. So if we substitute the value, and we will have negative 1 over 3 bracket, if we substitute 5 over 2, which means that 3 minus 5 over 2, and we will have 1 over 4. If we substitute 2, then we will have negative 1. So in here, we will have 7 over 24 plus 1 over 4. So after we simplify the situation, so that we will have the probability that x is greater than equals to 1.5 and less than equals to 2.5 will be equals to 13 over 24. So that will be the situation for the question C. Kindly refers to the question D, mode. Mode means that the highest probability. So kindly refers to the graph for the probability density function, and we have 2 over 3 as a maximum probability. So the mode will be x is equals to 2. So here we are, and thanks for watching.